Hello everyone. I'm going to do some examples from 7.3, applying some of these formulas. I'll be mainly focusing on the double angle and the half angle. Last time I showed you guys how to use the sum and differences. So this time I'm going to apply the double angle and the half angle formulas. Okay? And it'll just be a few examples, enough so you guys have an idea of how to apply the rest. So let's begin. Let's try to figure out how to apply any of these. So for example, if I want to figure out what is cosine of what's a good angle? Let's try 120 degree. Okay. Well, that's a pretty good angle. You don't really need any of these formula. You can just apply trig itself. So on the unit circle, this is 120. That is in the second quadrant. And if you're in 120, that means the reference angle will be 60. All right, that angle inside of this right triangle is a 60. We're on the unit circle. So cosine would call out the x value on a triangle of right angle with 60-degree angle. The adjacent side to the 60-degree would be 1/2. So this length is 1/2. So that means my x value will be 1/2, but it's in the second quadrant, so it's a negative 1/2. So this is going to be a negative 1/2. Okay, that's it. You don't really need this formula, but let's say you want to apply one of these formula. We actually have three choices. You have cosine of 2a is equal to cosine square a minus sine square a, or cosine of 2a is 2 cosine square a minus 1, or cosine of 2a is equal to 1 minus 2 sine square a. So to apply any formula, you do have to identify what variable is what. So in this case, if I want to apply cosine of 120 degree, I got to figure out what is my a, because that is the variable I need to plug in anytime I see an a. Okay, well, a is being multiplied with 2, and so 2a is going to be my input for cosine. It's cosine of 2a. In this case, it's cosine of 120. So where is my 2a? So I do have to rewrite it as 2 times something. And so 120 is 2 times 60, right? Twice of 60 is 120. So once you can write it as 2 times something, we are able to identify our a. And now we get to apply any of the three formulas. You can apply the first one, the second one, or the third one. I'm just gonna go with the third one. A little bit different because there's a sine function in there. But if I were to apply the third one, it would be 1 is equal to 1 minus 2 times sine square of what? Well, our a. In this case, my a is a 60. So it will be sine square of 60. Okay. And now we just have to evaluate. So this is 1 minus 2. This sine square of 60 just means that you're going to square the sine of 60. So let me just write that clearly. So what is sine of 60? Well, that's in the first quadrant, and it's going to be the opposite it is going to be the opposite of 60. Adjacent to 60 is 1/2, so opposite is root 3 over 2. So this is root 3 over 2. That's sine of 60. And you're going to square this guy. So squaring a fraction means top square. If I square the root 3, you get a 3. If you square the 2, you get a 4. So what is 2 times 3 over 4? It is the same thing as 2 over 1 times 3 over 4. So it's a fraction times a fraction, which is top with top, bottom with bottom. So it's 1 minus 6 over 4, or 1 minus 3 over 2. So how do I subtract two numbers? Well, this guy's a fraction, so I do have to rewrite that one as a fraction with a common denominator. So this one you can write as a 2 over 2. So then it would be just top minus top, but the bottom it would just be 2. So what's 2 minus 3? Negative 1. And it's a negative 1/2. Same as our original answer. Okay. And so yeah, with this example, you definitely do not need that double angle formula, but I'm just showing you how you would apply it if you want to apply it, but you don't really need it, okay? That 120 is a pretty nice angle. Any questions? So here's a better example. So let's say, for example, you want to take sine of 90 degree. Well, it's a pretty easy one, right? What do we know about sine of 90 degree? It's the y value at 90 degree. So at 90 degree, which is this guy, this is my point. So what's my y value? 1. Okay. According to my formula, I can write the sine of 90 degree. If I can write it as 2 times something, well, it's 2 times 45 degree. And once I'm able to write it as sine of 2 times something, that something is my a. So then sine of 90 is a sine of 2 times 45. And according to my formula, if you have sine of 2 times a, it's going to be equal to 2 times cosine of a, which is 45, times sine of a, which is 45. So cosine of 45 is root 2 over 2. Sine of 45 is also root 2 over 2. And after you multiply them together, well, multiplication of fraction is top with top, bottom with bottom. And if I multiply root 2 with root 2, I get 2. If I multiply 2 with 2, I get 4. And what is 2 times 2 over 4? It's 2 times 1/2, right? Once you simplify that, and that's a 1. Okay, so maybe you don't really need this double angle, because it seems like most of it you can just evaluate it just as it is. But we do need that half angle. So these two formulas are actually quite useful, but they're actually quite tricky, because you do have to decide at the very beginning if this is going to be a positive or a negative. And you have to do it early on, or else you're going to get confused between this angle and this angle. Okay, so let's begin. Okay, So a very good application of this would be any sort of an angle that is half of a nice angle. So let's say I want to figure out what is cosine of 15 degree. 15 degree is not a nice angle, but 15 degree is half of a nice angle. Okay? Now, before I even start writing it as half of something, let's decide. Cosine of 15, is this going to be a positive value or a negative value? Well, 15 degree is in the first quadrant, and cosine gives me back the x value. First quadrant, x value is a positive. So right before we even apply the half angle formula, I already know the sign to this trig evaluation. It should be a positive. Okay, so moving on to the next step, how do I rewrite this 15 degree as half of something? 15 degree is half of 30 degree. So now we've identified our B. Our B is 30. Okay, so now we just have to follow along the formula. So cosine of B over 2, cosine of 30 over 2 is equal to. Now this formula assumes that it could be negative or positive, but we already know it's positive, so we don't have to write that plus or minus. It's a plus. I'll just write that as a plus. And this would be 1 plus cosine of something over 2. What is that something? It's B. What is our B? 30. So 30 would go right there. Okay. Any questions? So just leave me a comment if you guys have any questions on this video. Okay, so now I just have to evaluate, and you don't have to write that positive. And what is cosine of 30? What is adjacent to 30? 30 is a nice angle. So let's figure out what is 30. So this would be 1/2. Root 3 over 2 would be my x value. So this is root 3 over 2. You do have to do some cleaning up. So let me just clean this up step by step. It is a complex fraction because you have a big fraction, but you also have a smaller fraction. So what I'm going to do here is multiply the top by 2, multiply the bottom by 2. You can do that, right? As long as you multiply top and bottom of a fraction by the same value. And so what will happen if I do that? Well, everything on top is multiplied by 2, so 1 times 2 is 2. And what is this fraction times 2? Root 3 over 2 times 2. The 2 will cancel, and you get a root 3. And the bottom is a 2 times 2, which is a 4. Now, everything is underneath this square root because you're taking the square root of the whole fraction. But you can separate the square root of a fraction by square rooting the top and then square rooting the bottom. And it's going to be equal to square root of 2 plus root 3 over 2. So this is my answer for cosine of 15 degree. Okay, that is if you decide to use the half angle formula. Is that the only way to figure out what is cosine of 15 degree by hand and not use a calculator? No, there is another way, and that is to use the difference formula for cosine. because here cosine of 15 degree, even though 15 is not a nice angle, I can view this as the difference of two very nice angles, and it'll be 45 degree minus 30. And we'll get to apply that difference formula from section 7.2. So cosine of A minus B is going to be cosine of A, cosine of 30, B. And what is it? If it's subtract, you're going to add. And here we are subtracting, so it will add. And it'll be sine of A, which is 45, and sine of B, which is 30. So cosine of 45 will be root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. And so our answer will look very different, but it's really the same value. So I believe I did this example in the section 7.2 video. So this would be root 6 plus root 2 all divided by 4. Okay, and you can compare the two. Let's see. And they look very different. So one of them is root 6 plus root 2 over 4. The other guy is square root of 2 plus root 3, all underneath the square root, and that's all divided by 2. And if you evaluate both of these radical expression, you get the same decimal value. So let me just show you what that should be. If I do cosine of 15 degree. So 15 degree, take cosine of that. It should be equal to 0.9659. Okay. And yeah, make sure it's in degree mode. It is. So if I take 15, I take the cosine of that, you get this. Okay. So this guy is also 0.9659. Okay, so I'm gonna focus on the half angle formula because they're quite tricky to apply, because you do have to recognize if it's going to be a negative or a positive right away. Let's do one more example. So let's try cosine of 120 degree. 120 degree. I can write that as half of something. So half of what? And before I even start to apply the half angle formula, I do want to decide if this is going to be a negative or a positive. Cosine of 120, well, 120 is in the second quadrant, and cosine is going to give me back the x value. And so if you're in the second quadrant, the x value in the second quadrant should be a negative. So cosine of 120 should give me a negative value. All right, so now to apply the half angle formula, I have to view this as half of something, and it's going to be half of 240. Yes, this example is a little bit ridiculous. You don't really need to do this, but for the sake of showing you how to apply the formula, we're just going to view it as half of the 240, okay? Okay, and we know it's a negative. So applying this half angle formula, I know it's going to be a negative in front right away. It's going to be a 2 in bottom, 1 on top, plus, and we're going to take cosine of b, b being the angle on top of that 2. So in this case, 240. So let me quickly complete this example. I'm going to do one more that's a little bit more meaningful. So cosine of 240, that is 60 degree more than 180. So if you think about it, that's in the third quadrant and 60 degree. And adjacent to 60 is going to be 1/2, but it's going to be a negative 1/2. And so this answer is going to be 1 minus 1/2 over 2, which is 1/2 over 2, which is 1/2 minus 2 is 1/4. If you take the square root of 1/4 is a 1/2. But remember, there's a negative in front the whole time. It's a negative 1/2. So the answer is a negative 1/2. Okay. All right, I went through this example pretty quick. You can pause at any point to check my work, make sure you understand every step. But let me move on to the next example. Okay, and so let me try a sine. So how about we try a sine of negative 15 degree. Now, before we even talk about the value of this guy, let's talk about the sine. So sine is going to give me back the y value. And negative 15 is in what quadrant? Negative 15 is in quadrant 4. So if you're in quadrant 4, right? If you're in quadrant 4, the y value in quadrant 4 is a negative. So sine of negative 15, I am expecting a negative value. Now let's apply the half angle formula. To apply the half angle formula, I have to view this negative 15 as half of something. And negative 15 is half of negative 30. So once I view that as half of negative 30, my b is negative 30. I'm just gonna follow this formula right here. Sine of b over 2 is equal to plus or minus, but we know it should be a minus, a negative, because we're in the fourth quadrant. And it's going to be 1 minus, there's a 2 underneath, minus cosine of b. So what is my b? So let's identify my b. B goes right here. This guy's my b. So b is on top of the 2, and it's the negative 30. Okay, so what is cosine of negative 30? This is something that we can evaluate by hand. It is in the fourth quadrant. And if you're in the fourth quadrant with angle 30, then this guy is 60, so the 1/2 must be over here. This guy is root 3 over 2. So at cosine negative 30, it is going to be a positive root 3 over 2. And now you just clean this up. At this point, it's just all algebra. We're going to multiply top and bottom by 2. And multiplying by 2 top and bottom will give me a 2. 2 times this guy would just be root 3 because the 2 will just cancel. And 2 times 2 is a 4. And then you can separate the square root on top, and don't forget about that negative. And square root on the bottom. And well, square root of 4 is a 2. You have this square root of 2 minus root 3. And here is my answer. Okay? So that's how you would apply these formulas from section 7.3. Try to do your homework. There's a lot more angles that you can apply using the half angle formula. And if you're stuck on any problem, just shoot me a message and I'll write up the solution for you. Okay, all right, I'll see you guys in the next video.